We have 3 more lectures, 19, 20, and 21. Then we will be done for this summer session. So this video is lecture 19. So I'm talking about functions, right? So all the time, I like to emphasize on, in mathematics, we talk about 3 things, right? Expressions, we simplify expressions, or we want to rewrite the expression in a typical form. And then equations, we solve equations, right? And the equation family, that's one branch functions. We use functions to model life. So to model life applications. So functions are indeed equations. You see, look, this function. This is an equation. But we use all the notation. All the notation, we would say y, right? We have 2 variables. All the notation. Usually the equation will have x comma y, right? Any point on this Cartesian plane, we use x value and y value to represent. X value is the value on x-axis. Y value is the value on y-axis. So in this one, the point is 4, 4. But in function world, we like to equal this y with f of x. F of x. And then also this we're going to call x, f of x in this case. X value is 4. And y value is f of 4, and we call this guy function value. Function value. So in this case, you see the variable is 4, x value is 4, and the function value at 4 is also 4. All right, so let's start. So let's look at A. What do we have to do? We want to graph function. So function has a couple of representations. It's like the same me, right? Same person, but at home, I'm a mom. In school, I'm a teacher. Or on the street, I'm just someone. So like in different kind of situations. So functions are represented in different situations as well. So 2 important way is one is algebraic. So this one, this expression, this equation is algebraic representation. And also the second one is graph representation. So usually those 2 are tied together to represent a function. So observe this function. We see we have the variable raised by square, right? We call this quadratic function or polynomial degree 2. Quadratic function or polynomial degree 2. So this is function. And quadratic function, we know we have a couple of representations. And usually we talk about standard form. Standard form of a quadratic function is we have ax squared plus bx plus c, right? That's a standard form. And we don't want a to be 0. If a is 0, that becomes a linear function. So this one in A, we call this a vortex form. Vortex form. The vortex form is f of x equals to A, then x minus h squared plus k. Okay. A times x minus h squared plus k. So in this case, the vortex is h comma k. So compared to the one we have f of x equals to 3 times x minus 2 squared plus 1. And 3 is A, so A is equal to 3. H equals to 2, right? X minus 2, so 2 is H. And K is 1. So we know the vertex of this one is 2, 1. So 2x value 2 is here, 1 is here. So this is the vertex. And because A is greater than 0. So we know this is upward, the graph is upward parabola. So for quadratic functions, we have two kinds of graph, either upward parabola or downward parabola. So upward parabola means the leading coefficient A, in this case, A, positive. Downward parabola means is when the leading coefficient A is a negative number. So we have upward parabola. Now maybe we want to find y-intercept, and we will not have x-intercept, right? Because this going upward will never touch x-axis. So find the y-intercept. Y-intercept x value is 0. So we just plug in 0 for the function. So 3 times 0 minus 2 squared plus 1. 0 minus 2 is negative 2. Negative 2 squared is 4. 3 times 4 plus 1. 3 times 4 is 12. 12 plus 1, 13. So the y-intercept is 0, 13. But 13 is off the chart. It's somewhere here. So our graph, let's see, right? It's somewhere high above there. Maybe a little bit difficult to show this. Right? And then it's symmetric. So the graph is parabola is always symmetric, something like this. Okay, so that's the graph this. If you want to be precise, you can always evaluate a couple more points. Let's see, we can evaluate f of 1, where x value is 1. Then we have 3 times 1 minus 2 squared plus 1. 1 minus 2 is negative 1, so let's do step by step. 1 minus 2 is negative 1 squared plus 1. Then negative 1 squared is 1. 3 times 1 is 3. 3 plus 1 is 4. So we get a 1 comma 4 point. So 1 comma 4. Yeah, to be exact, I could do this. Let me erase this. Then I know the graph is symmetric, right? So I can graph this way. All right, so that's the first one. And again, we won't be able to get x-intercept because you see the graph goes away from x-axis. If we try to solve 3 times x minus 2 squared plus 1, which is the function f of x, because x-intercept means the y value equals 0. So this equals 0. We try to solve and move 1 to the other side, becomes a negative. Then we divide by 3. Then we square root, right? We got a plus or minus square root of negative number. So we get a complex solution. So complex solution means the graph will never go cross x-axis or touch x-axis. We don't really have to do that. We don't really have to solve x-intercept for this case. Because A, the leading coefficient is positive, we know the graph goes upward. And we already have this vertex. So we don't really have to try to find x-intercept. Let's see B. B, if x value is 0, this first term is 0, this term is 0, we see f of 0 is 5. So with 0 comma 5 as a y-intercept. To find the x-intercept, we want to set the function to be 0. So plus 5 equals to 0. Right? X-intercept means the y value is 0. The function value is 0. So we can factor this. Because negative 2 plus negative 3, oh, that's wrong. Because we have negative 5, 6, 1. Because the negative 5 times the negative 1 is positive 5. Negative 5 plus negative 1, negative 6, give us middle term. So we get a 2 x-intercepts. X equals 5, and so we get a 5 comma 0 and 1 comma 0. 1 comma 0 here, 5, 0 is here. Well, let's try to find a vertex. So the only thing missing is the vertex. Okay. And the A is positive, so we know we have an upward parabola. So our graph, so we know this part looks somehow something like this. Yeah. And it's a symmetric. So this side goes this way. We just don't know down here, right? So we need to find a vertex. How do we find a vertex in the standard form? We have x value equals negative b over 2a. Right, remember a is the number before x. In this case, a equals 1. B is the number before, A is the number before x squared. And the b is the number before x, which is negative 6. So just plug into the formula of negative. B is negative 6 times 2 times 1. Negative, negative, positive. So 6 divided by 2, that's a 3. So x value is a 3. X value is 3. We need to find f of 3. F of 3, so we have 3 squared minus 6 times 3 plus 5. 3 squared is 9. 9 minus 6 times 3, 18 plus 5. Well, 9 plus 5, 14. 14 minus 18, negative 4. So our vertex is 3, negative 4. 3 right in the middle, 4 right here. That's our vertex. So our graph it has to be roundish, not straight, roundish. Cut it smooth, something like this. So the vertex is a 3, negative 4. And x equals 3 is the line of symmetry. X equals 3. So this line is called x equals 3. It's a line of symmetry, which means if we fold the left-hand side of the graph to the right, it overlap. Let's see C. C is similar to B, right? It's because it's in standard form. So the y-intercept is obvious. It's a 0, negative 1. So we can graph 0, 0, number 0, negative 1. Then x-intercept, we have 2x squared minus 4x minus 1. We want to set this one to be 0. Then maybe move negative 1 to the other side, become positive. So I have 2x squared minus 4x equals to 1. Divided by 2, because we see 2, 4 has common factor of 2. We get x squared minus 2x equals to half. Then add 1 on both sides. We want to make this a perfect square. So we get x minus 1 squared equals to 3 halves, right? Because 1 is 2 over 2. Then square root both sides. The plus minus square root of 3 over 2. So we get x minus 1 equals to plus minus square root of 3 over square root of 2. We can simplify this by multiply by 1. And this 1 is square root of 2 divides itself. So we get positive, negative square root of 6 divided by 2. Then move 1 to the other side. 1 plus. So x equals 1 plus square root of 6 over 2. And 1 minus square root of 6 over 2. Or you can write together as plus minus. So how do we graph? Those are irrational numbers. How do we graph this? Let's think about square root of 6 first. Square root of 6 is in between 3 and 2, right? Because 2 is the square root of 4, 3 is the square root of 9. So this is the square root of 9. This is square root of 4. And 6 is closer to 4, right? Because 6 minus 4 is 2. 9 minus 6 is 3. So 6 is a little closer to, square root of 6 is a little closer to 2. It's 2 point something. Now let's divide by 2. So we divide by 2, divide by 2. Then let's add 1. So 1 plus square root of 6 divided by 2 is in between, well, again, let's multiply by this, in between 5 over 2 or 2.5, right? And this side is 1 plus 1, which is 2. So it's in between 2 and 2.5. In between 2 and 2.5. So somewhere here. So that's this point. Yeah, that's this one. That's this x-intercept. So for two x-intercept, right? We have this number, comma 0, and this number. Now what to do? How do we do this one? So we do the same thing. We have square root 6 in between square root 9 and square root of 4. Then we divide by 2, we divide by 2. Then, but because we have negative, so we negate. When we negate, we switch the sign. So we negate, we have square root 6 divided by 2. Greater than negative square root of 9 over 2. Then less than, or 2 over 2, 1, less than negative 1. Then we add 1 to it. We add 1 to it on three sides. So we got 0. So 1 minus square root of 6 over 2 is in between 0 and this is 3 halves, negative half. 1 minus 3 halves is negative half. So that another irrational number is in between 0 and negative half. So negative half is here. So in between somewhere here. Right. And the A, our leading coefficient is positive, so we have an upward parabola. So this side will have something like this. Right. But let's find our vertex. So vertex, x value equals to negative b over 2a. In this case, b is 4, a is 2. So negative 4 over 4, that's negative 1. Then f of negative 1 equals to 2 times negative 1 squared. Just plug into the function. Plus 4 times negative 1 minus 1. Negative 1 squared is 1. 2 times 1 is 2. So 4 times negative 1 is negative 4. Then minus 1. So 2 minus 5, which is negative 3. So our vertex is negative 1, negative 3. Oh, hold on, something's wrong. Because this is a negative b over 2a. Yeah, negative 4. Our y-intercept is 0, comma, negative 1, 0, comma, negative 1. That's right. That's impossible. How can we, so y-intercept 0, 0, negative 1, yes. Then vertex is a negative b over 2a, which is a negative 1. Negative 1 and negative 3 are okay here. Negative 1, negative 3. So this point must be wrong because we have upward parabola. Let's see. So when we solve for x-intercept means the function value equals 0. So we need to solve for x. So we move negative 1 to the other side, become positive 1. Then we divide by 2. We get x squared minus 2x equals a half. We plus 1 on both sides. That's 3 halves. Then 1 plus or minus square root 2, right? 1 plus or minus square root 6 over 2. That's right. So then, 1 plus square root 6 over 2. We have calculator here. That's in between 2 and 3 halves. Between 2 and 3 halves. And then we have positive. We have upward parabola. So the graph looks weird, isn't it? And the 1 minus square root 6 over 2. 1 minus, that's in between 0 and this. Negative b over 2a. Okay, you know what? Let's redo this. So y-intercept is the easiest one. It's a 0 plug in 0. Right? This would be 0, this would be 0, left with a -1. So 0, -1. That's our y-intercept. Then x-intercept we need to solve. X-intercept means the y function value is 0. So that means 2x squared plus 4x minus 1 equals to 0. So move -1 to the other side, become +1, divided by 2, get x squared plus 2x. Somehow I changed it to be minus 2x, right? That's the mistake. Plus 1 equals to half. So we have x plus 1 squared equals to 3 halves, because we need to add 1 on both sides. Then square root, we get x plus 1. X equals -1 plus minus is square root of 6 over 2. Okay, before I had the positive 1. Okay, now it makes sense. That's -1. The mistake I have made previously is this one is not negative, this one is positive. Now when we calculate square root 6, that's in between 3 and 2. We divide by 2, divide by 2, divide by 2. Then we do -1, right? -1 is same as -1 plus this. So -1, -1. So this is going to be in between 0. 3 halves -1, that's half. So in between 0 and a half. So -1 plus in between 1 and a half. 0 and a half. So the first x-intercept is this. Then the second intercept is because it's negative. Negative square root 6 over 2. That has to be greater than -3 over 2, less than -1. Then we -1, -1, -1. That's in between -2 and -5 over 2, or 2.5, -2.5. So in between 2 and -2.5, so somewhere here. Then our vortex, x equals to -b over 2a. b is 4, a is 2, so we get -1. F of a -1, that's 2 times -1 squared. Just substitute into the function 4 times -1 with -1. We calculate this. -1 squared is still 1. 2 times 1, 2. 4 times -1, -4, -4, -1. So that's -3. So -1, -3. So right here. Now it makes sense. So now our graph goes this way. Right, the symmetry is x equals the line of symmetry is x equals to -1. Okay, so that's the graph of this one. Okay, now let's see some word problems. Let's see 2. To see if the sum of two numbers is 20. Well, let's call one number x. Let's call the second number y. The sum is add those two numbers. That's 20. What is the largest possible product of those two numbers? Well, largest possible product. Product means multiply those two, right? Equals to, we don't know what equals to. So let's see, product, let's call P. So we have these two equations given. So how do we, manipulate those two equations to get a function? Okay, so the first one gives us y equals to 20 minus x. So we're going to substitute into the second equation. P now, the product equals to x times y. Y is 20 minus x. 20x minus x squared. Well, let's write this in order. That's -x squared plus 20x. A quadratic function. Now we can call this p of x. Just like f of x, right? Product in terms of x. So the picture is a downward parabola. because the leading coefficient is -1. In downward parabola, the vertex is called a maximum. So if we're looking for largest possible product, that is the function value of this point, right? This point, remember, we call vertex. How do we find a vertex? Remember, x value equals -b/2a. Where do we find the b? B is a number before x, in this case 20, times 2 times a. A in this case is -1. So -20 divided by -2. Well, negative become positive. 10 divided by 20 divided by 2, that's 10. Now I need to find possible. So when the x value is 10, the product is the biggest. So now we can evaluate p of 10 product with x equals 10. So we get -10 squared plus 20 times 10. -10 squared without parentheses, because this negative is outside. Right? The square has nothing to do with this negative. Get -100 plus 20 times 10, that's 200. Well, -100 plus 100, that's plus 200, that's 100. So the largest possible product of those two numbers is 100. Right? So x value is 10, y value is 10. Okay, that's 2, let's see 3. You have 20 feet of fencing to enclose a rectangular area. Let's grab a rectangular area. That bordered a river. Let's see, this side is a river. If you do not fence the side and the border is a river, so that means this side doesn't need a fence. We only have to fence this, this, and this. Let's call this shorter side width, the longer side length. Right? So we want to have to border this way. So we're given 200 feet. So that means we have 2w plus L, W plus W, W plus L plus W, right? That's 2W plus L. That equals 200 feet. And then if you don't fence the side of the river, what should the dimensions of the rectangular area be? The largest possible. Again, remember the area. The area equals to length times width. So a very similar strategy, to 2. 2 is talking about two numbers, right? We're given sum of two numbers, then the possible biggest, largest product. Well, in this case, we're given the relationship between the length and width, and we're looking for the possible biggest area. So from the first one, we can write L, the width, the length in terms of width, which is 200 minus 2W. So then we just substitute L into W. W is W times 200 minus 2W. You see, from here, we can call A a function in terms of width, W. W times 200, that's 200W. W times -2W, that's -2W squared. Right. Again, we see a downward parabola because the leading coefficient -2 is negative. So it's a quadratic function. And when we want to find the largest area, we want to find this vortex, the function value of this vortex. So the function value of the vortex is W, because the variable is W. Let's write W equals to -b/2a. So B is a number before W, before the variable, is 200, divided by 2 times A. A is a number before W squared, which is -2. But we have two negative signs in product or division. So negative become positive. We have 200 divided by 4. Well, 4 goes into 250 times. Well, 4 times 50 is 200. So the width is 50. The question is asking, what should the dimensions be? Dimensions means the width and the length. So the length we have here. So that's 200 minus 2 times W. W is 50. That's 200 minus 100, which is 100. So to answer the question, to cause the biggest area, the length of the rectangle is 100 feet, and the width is 50 feet. So you see, this is how we use functions in life applications, you know, by using the known conditions, known data, we form a model. In this case, the model is a function, is a quadratic function, right? Very useful. Quadratic function is very useful in life applications. Okay, now we're going back to linear functions. So finish the quadratic function, we're going back to linear functions. Remember in high school, we have y equals mx plus b form, something called a slope-intercept form. This in high school. Maybe some of you have learned slope-intercept form. Because why? Because m is the slope, 0, comma b is the y-intercept. Okay, and also find, okay, we want to find a distance. We want to find the distance between those 2 points. Let's graph those 2 points. 1, 2, 3, 4. So this is 4, 5. Then we have 1, 2, 3, 4, 5, 6, 7. So let's say this is 7. 1, 2, 3, 4. This is 4. So 1, comma 4, we have this point. 5, comma 7, we have this point. So we want to find the distance in between those 2 points. So how do we find that? We're going to use Pythagorean theorem. We draw horizontal line parallel to x-axis. We draw vertical line parallel to y-axis. This is the y-axis. This is the x-axis. So we have made a right triangle. And the distance is a hypotenuse. Let's call this D. Is a hypotenuse of those 2, like sum of those. So Pythagorean theorem, right? D squared, D equals square root. Let's find the length of this base. So here is 1, the value is 1. And here the value is 5. So the distance should be 5 minus 1, which is 4. So 4 squared plus, and the y value here is 7. Y value here is 4. So 7 minus 4, that's a 3. So 3 squared, which is square root of 16 plus 9, which is the square root of 25, which is 5. So this D equals 5. So find the distance of any 2 points. We just use Pythagorean theorem. So we imagine that's a right triangle, right? The hypotenuse square equals the sum of 2 legs square. So in algebra, let me make a picture here. Let's see, I have 2 points. Let's call this point x1, y1. Let's call this point x2, y2. Then the distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Just like what we did here, right? If we call this point x1, y1 point, this point, x2, y2 point, we see we have x2 minus x1 to get 4, but y2 minus y1 to get 3. So the distance between those 2 points is 5. Let's see this one. We want to find the middle point of those 2. So the middle point, let's see if we want to find the middle point of this one, right? That will be here. So actually, the middle point formula is, let's call this x1, y1, this x2, y2. So the middle point of those 2 points is as average. So add x1 with x2 and divide by 2. Average value. add y1 with y2, then divide by 2. So in our case, 3 plus -2 divided by 2. -4 plus 6 divided by 2. 3 plus -2, that's -1, so we're going to -half. Then -4 plus 6 is 2. 2 divided by 2 is 1. So the middle point of those 2 points is -half and 1. Now let's say 6. Write the standard form of the equation of a circle with the center at the origin and radius 5. So imagine the circle centered at the origin and the radius is 5. This is 5, 5, -5, -5. So the circle. So this is the graph of the circle. It's not a function. It's not a function because it fails vertical line test, right? If we put a vertical line, the vertical line cuts the graph into 2 points. So it's not a function, but it's 2 functions. Right? If we only consider above x-axis, the semicircle, that makes a function. Down below, it makes another function. So the standard form, we also use Pythagorean theorem, right? Just imagine this is the any point. Let's call x, y. Then in this case, this is a special case because the center at the origin. It doesn't have to be center at the origin, right? We could have a circle anywhere. Let's say center is h comma k. Right, let's say this is the center. Then we can use distance formula. Let's finish this one first. You see in this one, this is the x value, this is the y value. Do you see x squared plus y squared by Pythagorean theorem again equals radius squared. Radius squared in this case is 5 squared. But that's it. That's the equation for this one. From this rectangle. X squared plus y squared equals 5 squared. But normally, circle doesn't have to be centered at the origin. So what do? So the center, let's call it h comma k. So we can have another point somewhere. And we can imagine another rectangle. And we want to use this again, the Pythagorean theorem again. So let's call this point x comma y. And we see the equation of this circle is the radius squared. Let's call this radius r. Radius squared equals to x minus h squared plus y minus k squared. Right? Exactly this right triangle. X minus h is this distance, is this one, the base, square, plus y minus k is this height, square, equals to the radius square, r square. So in our case, it's just this, right? Because we have x minus 0 square, our center h comma k is just 0, 0, plus y minus 0 square equals radius square, radius 5. So in the end, we can write out x squared plus y squared equals 25. So the equation centered at the origin is always x squared plus y squared equals to radius squared. Let's see 7 and 8. 7, write the standard form of the equation of a circle with this center and this radius. So let's recall we have x minus, maybe any point, let's call x, or no, h comma k. The center we call h comma k. X minus h squared plus y minus k squared equals to radius squared. In our case, h is 3. X comma y represents any point on the circle. So x minus 3 squared plus y minus -4 squared equals to 7 squared, because radius is 7. Simplify a little bit, we have x minus 3 squared plus y plus 4 squared equals to 49. That's it. So this one, number 8, we want to find the center and the radius of the circle. And given equation is this. Remember, we have x minus h squared plus y minus k squared equals to r squared. So we need to identify h comma k, which is the center, and the radius r. Well, x minus h, but here we have x plus 1. So that's x minus -1. So h is -1. And k is y minus k, y minus 2. So k is 2. And radius is something squared. It's a 3 squared. So radius is 3. Okay, that's it. So 19 total 8 questions.